Hello and welcome to this explainer. If you're a focused learner trying to unravel the absolute complexities of managing modern AI data centers, well, you're in the exact right place. Today, we're going to explore Supermicro's SuperCloud Composer. We'll see how it literally brings order to the chaos of high-performance computing, taking us all the way from the physical realities of power and cooling right down to the Kubernetes architecture that makes the whole shebang tick. Let's get into it. Okay, let's dive into this roadmap. We've got a lot to cover. First, the data center observability problem. Second, we'll meet SuperCloud Composer. Third, we'll look at its modular software stack. Fourth, defining rack-scale design. Fifth, the Kubernetes and Redfish foundation. And finally, intelligent integration and scaling. Section 1, the data center observability problem. Now, what's really interesting to consider here is the visceral pain of managing infrastructure when you're flying completely blind. Imagine running these incredibly demanding AI workloads, right? But suddenly, you've got multiple critical alerts firing across entirely different infrastructure domains at the exact same time. Without a centralized system, there's just no way to quickly find the root cause. You've got a cooling alert over here, a server warning over there, so which one actually caused the other? It's like a giant puzzle with missing pieces. This lack of unified observability leads to massive, timely delays in diagnosing issues, and ultimately, extended, catastrophic downtime. And when your systems are disjointed like that, a cascade of failures is literally always just around the corner. We aren't just talking about a sluggish app, we are talking about physical infrastructure disasters. Without centralized management, you face undetected server failures from severe overheating. You risk sudden power losses just because an unmonitored PDU, a power distribution unit, simply tripped. And maybe most dangerously in today's liquid-cooled AI environments, you risk CDU component failures. Just one undetected coolant leak in a coolant distribution unit can completely cripple your operations in minutes. No way you want to deal with that. Section 2. Meet SuperCloud Composer. So, to stop the bleeding, you desperately need a control center. Enter SuperCloud Composer, or SCC. This is essentially your ultimate command dashboard. It gives you unified observability and policy-driven monitoring across every single critical domain: servers, GPUs, network, power, cooling, the works. And it does this at both rack and pod scale. It's specifically designed for those highly complex, power-hungry AI workloads we're seeing everywhere today. Things like deep learning frameworks, massive LLM inferencing, and GPU-accelerated cloud-native clusters. It's highly scalable monitoring, purpose-built for massive server fleets. But here's the kicker. SCC doesn't just sit there and watch, it acts. Its core capabilities include real-time health monitoring and sophisticated alerting. Think SMTP, webhooks, and direct integrations into ITSM platforms like ServiceNow. But the real magic? That's in its policy-driven automated actions. If SCC detects an environmental hazard, like, say, a coolant leak, it can automatically shut down systems. It can disable smart PDU outlets to instantly isolate affected equipment, and operationally, it manages FRU, Field Replaceable Unit, reconciliation, making absolutely sure you maintain a perfectly accurate asset inventory whenever hardware gets replaced. Section 3. A modular software stack. The Supermicro Software Suite features this incredibly smart, independent but integrated architectural hierarchy. What does that mean? It means customers can deploy exactly what they need. At the top, you've got SuperCloud Composer for your monitoring and telemetry. Right below that is the SuperCloud Automation Center, or SCAC, for infrastructure provisioning and cluster deployment. Then there's SuperCloud Director, or SCD, for multi-tenant bare metal lifecycle control. And finally, the SuperCloud Developer Console, or SDX, for fractional GPUs and on-demand scalable developer environments. You can run just one piece, or you can run them all seamlessly integrated. So the crucial point is that this modular architecture allows for incredibly flexible consumption right from day one. You aren't forced into some massive monolithic platform if, hey, you only need monitoring. This entirely avoids those massive single-platform dependencies, heavily reduces vendor lock-in, and really mitigates the operational and security risks of putting all your eggs in one software basket. It's built to adapt to your specific priorities, not the other way around. Section 4. Defining rack-scale design. Now, rack-scale design is a true paradigm shift. It means SCC models and manages your infrastructure at the actual physical rack level, rather than just treating your data center like some giant, flat spreadsheet of individual servers. It gives you true physical spatial awareness. This allows you to really map and correlate the immense power and cooling dependencies that are absolutely inherent to modern AI infrastructure racks. To put that into perspective, in traditional flat list management, an alert just tells you server X is running hot. Okay, but you have almost no context. With rack scale context, though, that alert tells you that multiple systems in, say, rack Y are heating up, and it directly correlates this to a specific coolant distribution unit or PDU. This means operators can take emergency action on entire groups of racks if a CDU leak is detected. For AI infrastructure, having that exact physical context is absolutely vital. Section 5. Kubernetes and Redfish Foundation. And this brilliantly illustrates SEC's modern approach to server management. On one side, you have the Redfish API. This is a modern, highly secure REST and HTTPS-based open industry standard. It gives you this rich, rack-scale visibility for system health, power, and thermal data. Contrast that with legacy IPMI or SNMP, which are frankly much less suited for secure, modern automation. By leaning into Redfish, Supermicro significantly reduces vendor lock-in and aligns perfectly with scalable, encrypted, rack-level operations. Furthermore, SEC's internal services actually run on a Kubernetes foundation, which is what guarantees all this modularity and resilience. Let's look at its high-availability design step by step. Step 1 is the control plane, which needs to run on 3 separate nodes for complete resilience. Step 2 involves the worker nodes. These guys handle the heavy lifting, running background jobs, telemetry processing, automation tasks, all without stressing out the control plane. And step 3 is strategic sizing. You really have to evaluate your telemetry volume and rack count. Endlessly scaling a single cluster isn't always the answer, you know. Sometimes deploying a separate SEC platform for different physical sites is just the smarter architectural choice. Section 6. Intelligent integration and scaling. To make all of this hum, SEC aggregates a massive wealth of data from incredibly diverse sources, using both out-of-band and in-band telemetry. Out-of-band telemetry uses BMC interfaces, which means it requires absolutely no OS agent. It captures hardware health, power, and thermal data completely independently, even if the operating system crashes. In-band telemetry, on the other hand, surfaces resource-specific metrics directly from the OS using provider exporters. We're talking about pulling rich data from Nvidia DCGM for your GPUs, AMD ROCm SMI, Bluefield Doka, and cloud-native storage systems like Weka or VAST. It really is the best of both worlds. And we absolutely cannot forget power management. SEC deeply integrates with a massive list of smart PDUs from top vendors. Think Raritan, Schneider, ServerTech, and Eaton. But this isn't just about reading power draw. This integration unlocks network data logging, precise server-to-outlet mapping, and the ability to trigger graceful shutdown thresholds directly from the SEC dashboard. It literally transforms dumb power strips into intelligent, active participants in your overall infrastructure's health. Which brings us to our final thought. I want you to look closely at your own operations. Is your data center infrastructure truly observable? Do you actually have spatial awareness, automated policies, and the modular stack guiding your actions? Or are you just sitting in the dark, waiting for the next alert to trigger the next massive fire drill? SuperCloud Composer offers a real way out of the chaos, turning complex data into clear, actionable intelligence. Thank you so much for joining me on this explainer. Keep learning, keep optimizing, and I'll catch you next time.